diameter PVC pipe that comes up inside here, and the reason it's inside that is as cows eat hay, grass, whatever, they tend to drop some in the water tank, and if you're relying on an overflow system to keep your tank from freezing, water has to be able to flow through it. If you get grass and hay and debris in there and it plugs the drain and you're not overflowing, it's obviously going to freeze up. But the riser pipe in there, in the summertime, we just set those floats so that the top of the drain pipe extends about 1 inch above the static water level set by the float. In the wintertime, just raise the floats 1.5 inches, and then the water level goes above the top of that drain, and there's water always flowing through it. This is why I say you need to have abundant water for the system to work. Then there's a drain pipe goes from this just to a low area, and the water drains away. There's a valve made by the Walters valve company in Oklahoma that has a thermocouple in it that automatically, as long as the water temperature is above a certain level, and you can set it for what you want, 35 degrees, 37, something like that, you set the valve so that when the water temperature drops, we'll say to 35 degrees, it opens a secondary valve that starts circulation. And so you only overflow water when the tank is at risk of freezing. All the rest of the time, it's kept at that level below your overflow pipe. Those valves, I think they cost about $80 these days. And if you have pretty good water availability, but you don't want to run full time, you can use that sort of valve that only runs when you're at risk of freezing. So that's another option you can put in the tank, use an overflow system, but it's kind of a regulated overflow system. Another thing that you can do on spring developments is do what we call a cascading tank system. And in a system like this, again, you require enough water, but there's no float valves in these tanks at all. The overflow, this is tank number 1, water's coming in here, just no valve on it, just steady flow of water. The blue line is the overflow for it. It becomes the supply line for the next tank down. The yellow line is the overflow, becomes the supply line for that one. And so you just have continuous water flowing through all of these tanks, and it's really as little as 5 to 10 foot elevation drop between tanks, and a system like this will work. The cool thing about this is it essentially uses the same water to keep all the tanks open. It's only the last tank in the system that actually drains out. So it's another way, if you have a spring development fairly high on your property, that you can put a series of tanks across the property. It might just be 2 tanks, it might be 3. One of our clients in Nevada, when you go to Nevada and you're in the ranch community, you better say Nevada and not Nevada, because it's only Californians who call it Nevada. And there's not many things lower on the face of the earth in Nevada other than a Californian. So just keep that in mind. Probably if you go to Las Vegas, it doesn't matter. But if you're in the ranching country in Nevada, make sure you say Nevada. All right, we have a client in Nevada who has about a 20-mile pipeline with 15 or so tanks. Tank every mile. It's all downhill gravity, and flows the water through all the tanks for 20 miles to do that. You can do it on a big scale. You can do it on 40 acres with 2 tanks on 200 yards of pipeline. But it's a good, reliable system for keeping water open all night. Spring-fed or large ponds, the best way of doing it. If you're going to pump it, obviously, because you have continuously flowing water, you've got a steadily running pump, and that can get pricey. Some other things on water. This is a Covet water up at the research station at Lydius. About the time I was leaving, they were putting in a lot of these Covet waters. They're geothermal heat tank. You know, there's I think these went about 8 foot into the ground. So you have a heat well that comes up, keeps it from just a small drinking cup. That's what I didn't like about them, was the limited drinking aspect. You can see some green leaves on the tree, so this obviously isn't winter. In winter, I think they probably work pretty well. In the summer, even though the company says you can, run 100 head to one of these waters in the summertime, it sure didn't look like a low-stress approach to watering for me. I wasn't particularly crazy about these. They do work very well at staying open, though, even to some fairly low temperatures. These are the jug waterers. It's another geothermal heat one. But again, it's limited drinking area. If you're looking at 20, 30, 40 head, a single one of these units, works fine. If you have larger heads or larger herds, you put in a whole battery of them at drinking point. That gets to be pretty pricey. These ones also they're pretty reliable for staying open in the winter, but the cost per head to me is a little high. This device here, not a real good picture, but there's a air compressor, a DC air compressor in there, and a battery in the box, solar panel here, and the air compressor just runs continuously. And just like flowing water won't freeze, continuously aerated water won't freeze either. And so you just constantly run bubbles into the tank. When we use these, we would put a T in the line and have one column of bubbles coming up where the float was in the tank, so that and then one column coming up at the edge to create a drinking space for it. And so that way your float valve, your control valve, still worked in the winter because it didn't freeze around that. You had a drinking point there. The rest of the tank could be frozen up, but it still worked. So when we first encountered these, they were only like $260. And if you had, half a dozen tire tanks around, you could just move it tank to tank as you move the herd and keep water open. You could basically take any kind of an open stock tank and turn it into a year-round waterer. I think they're up over $500 now, so they're a little less attractive unless you have the number of animals that will pay for something like this. So there's a lot of different alternatives that you can do in winter water. Now, moving along, we're going to look at this piece of property. It's 140 acres. Had just been a big open pasture, had one pond on it. Maximum travel distance to water would have been about 2,000 feet. And I just want to kind of contrast pros and cons of approaching your pasture, your farm, with a fixed grazing cell design or a flexible cell design. This one, it says a 16 paddock system. There's nothing magic about 16. It could have been 12, could have been 17, could have been 23, could have been 9. Just the way it's laid out here, it's in 16 pastures. If you don't do any further subdivision in there, and you think about typical rest requirements in the summer, that gives you the flexibility of maybe as little as 2 days in a pasture and 30 days, 30 days, 2 days on a pasture, 30 days of rest, maybe all the way up to 5 days on a pasture, and 75 days of rest. But what you don't have much flexibility here. Those pastures are always that size. We put a pump over here at the pond, put a pipeline system in. There's 1, 2, 3, 4, 5 permanent water tanks out there. This is a buried pipeline going to tire tanks. There's a lane put in, so it's easy to move the animals from one point to the other. So that's what a fixed design on a piece of property like that might look like. And you'll notice a lot of the fences are running crooked and stuff. That's because they're fitted more to the landscape. There's some straight fences, but there's crooked ones there. Do you need a lane? In a beef operation, I largely say no. It's convenient sometimes to have a lane for moving critters around. In a dairy situation where you have to get cows up and milk them, once, twice, 3 times a day, whatever you're doing, lanes are very important. Some of the things to think about with lanes outside of the dairy scenario is, it can become wasted area, site for erosion to begin. This was 1993. Y'all remember 1993? Up at Linnaeus, we had 32 inches of rain in May and June. This was one of our lanes on at that time we were doing fixed systems. A 24 paddock system had a stock tank at each end of it. That was the water for the pasture. 2 tanks at the end of the lane, so they're used every day. And this is what they turn into in wet situations. So I kind of got burned out on lanes in those days. If you do need a lane, with the tools we have available now, with easy-to-use reels and poly wire and step-in posts, create a lane to get them to the corral. It doesn't take very long to put up a quarter-mile, half-mile lane to get them from the back of the place up to the corral if you need to. So we kind of lean more that direction now if you need one. Another problem with lanes is, and permanent paddocks, is it gives you lots of gates. And the expensive part of electric fencing is, like any kind of fencing, it's ends and gates. It isn't just the wire running out there, it's ends and gates are the expensive part of electric fencing. So if we can minimize those, we want to. So this is one of the ways of creating gates without cutting your wire and having end posts. It's what we call a lift gate. In this case, 2 pieces of PVC pipe. Some people do it just one. And we just raise the wire, and the cattle can walk under it to get in the lane, go to water, go up to the dairy parlor. So don't get locked into the idea that a gate is something that swings and goes this way. A gate is simply a place where stock can cross over, or it's under or through a fence. Yes?
Did you get them to adapt to go through there pretty easily?
Pretty easily. You only need 1 intelligent cow, and most herds have at least 1 intelligent cow. And you get her to come through, and the others will start coming. We've had, clients who've been pretty skeptical of this, and that it wouldn't work. And after they try it, work with the animals a little bit, and maybe entice them through with a little, with some range cues or something. Most of them, within 4 days to a week, have the entire herd routinely using these and going through. If you have 1 or 2 head that never figure it out, to me, again, that's calling criteria, get rid of them.
So how high is that gate, that moving gate?
Probably a minimum of 6 feet. 6.5, 7 feet is what I typically see in that.
Okay, the reason why I'm asking, how do you get that slack in the wire once you set it down?
Number 1, you don't have to put the wire up finish string tight to begin with. Depending on what your post spacing is, depends on whether you use 1 of these lifts or 2. Now, what some people do, actually, like the PowerFlex posts, where you have the cotter key wire attachment, is rather than bending the tails of the cotter key, back around the neck of the eye or anything, they just kind of, fold them at 90 degrees so that they can be pulled out of there, and then they actually set the PVC pipe, lift the wire up, set the PVC pipe down over the PowerFlex post, and that prevents the animals from being able to ever knock that piece of pipe down. And you don't need as much slack in the wire to do that, because let's say if you're at 50-foot post spacing on your PowerFlex post, if you do this, you're going to be lifting within a 50-foot span, and it can be pretty snug. But if you take the wire loose from one of your posts, you're lifting it across a 100-foot span, and it's a lot easier to have the slack in.
Now, is that actual wire or is that poly wire?
That's actual high tensile wire.
Cool.
I read about a guy in the south